So in today's webinar, I'm going to be demonstrating and explaining the CYPEPLUMBING Water Systems and Sanitary Systems. If at any moment you have any doubts or questions, please let me know in the chat. So just while we wait for everybody else to join the webinar, I'm going to take this time to explain a little bit about who we are at CYPE, what our goals are, and some of our recent achievements. I have a quick presentation here, which will cover just that. So if you watched the previous water systems and sanitary systems webinar, you'll recognize that this is going to be very similar. Okay, I'll try and get through this quickly. So to get started, CYPE has a suite of programs for hydraulic installations. This suite, along with all of such programs, has a focus on energy efficiency, economical use versus economical installation, and a comfort levels concepts. In the modern world, we believe that incorporating these concepts into our programs is necessary and is what separates us from the alternative offerings. In the era of global warming, it's essential for us to not only provide the analysis of systems that meet normative standards, but that also achieve the greatest efficiency possible. So you'll see when I'm demonstrating the programs, I'll point it out that we, at the core of the programs, we have the concept of deciding between economical use versus economical installation, and all the programs include these different comfort level concepts as well. But I'll demonstrate those when we're demonstrating the program. Sorry. Okay. So CYPE is a Spanish company that has been developing technical software for architects, engineers, and construction professionals for well over 30 years. The huge variety of programs and the disciplines they encompass are currently in use all over the world, with more than 70,000 users in over 60 countries. Amongst the clients are city councils, technical organizations, universities, and professional offices. Starting in Europe with a focus in the south, CYPE has more than 40,000 clients in this region. It's very important to mention that the calculation conducted by CYPE software is certified by the governments of these countries, a certification which requires the analysis, the results of our analysis to meet rigorous standards. With more than 15,000 clients, CYPE is one of the most used software for structures, building services, and management in Latin America. We have more than 20 distributors selling our software around this region. In Africa, there is significant presence in the French and Portuguese-speaking countries, where we have seen a 250% increase in the last 4 years, and the development of the official software for thermal calculation and energy certification in Morocco. And in the USA, India, and Australia, as well as many other countries, we are landing with our suites for efficiency calculation and structures, with our new headquarters opening in Atlanta, USA in 2016. A principal component of the workflow is that all of the work is based on the open IFC file format, meaning that if CYPE was to cease existing, all the information created for your projects is free to be used with any other BIM modeling software. So when we analyzed the construction industry, we noticed a lot of inefficiencies between the different gears that make up the industry. Due to the errors generated by the communication of work between different disciplines, projects are constantly over budget, as these errors originate from a fundamental lack of communication and are hard to predict. We want to remove the boundaries that exist between the professionals in construction, plumbing, HVAC, etc. We spoke to the government, who routinely heard that a project would cost them $2 million and end up costing them double. If we can make the communication seamless, then we can remove a lot of the inefficiency that occurs in construction projects, and we can reduce the wide gap between projected construction budgets and those actually delivered after completion. Sorry. So what have we done? We've conducted extensive research into how to remove these communication barriers. The international and national research projects which we have conducted in conjunction with manufacturers and researchers revealed a common solution. The old method for construction projects using CAD models creates barriers between professionals and is the source of a lot of additional costs. Moving to a BIM model enables significantly improved communication between professionals However, it does not take full advantage of the potential that exists in the technology. We have created a BIM workflow that takes full advantage of the technology to enable the simultaneous completion of work with improved flexibility, interoperability, and integration between different professionals. Here I present the fundamental concept of the BIM workflow. This diagram depicts the iterative nature of a simultaneous workflow. As professionals take information, work, and export, it flows in a cycle that enables the seamless communication between all disciplines. I will explain this in context now. So this is how the workflow works with the hydraulic suite, which I'll be explaining today. You can start in the top left corner. You can start in the top left corner with our architectural model, which loads directly into the BIM Service Center and begins the cycle. So if we move towards the BIM Service Center, here's how the system works. Starting with the architectural model, each of the disciplines receives the BIM model and conducts their analysis. For structural analysis, electrical analysis, etc. Each of those feeds their results back into the Service Center, where the BIM manager collates it all. If any changes are required, perhaps by the HVAC installation, the architect can adjust the building model, re-upload, and the changes are automatically updated for all the other disciplines. They simply recalculate and all the information is fed back into the program on the BIM Service Center. So, to begin, the IFC BuildUp. If you aren't familiar with IFC BuildUp, it is a free SYPE application designed for the creation and maintenance of IFC building models. It's simple to use and integrated in our OpenBIM workflow. Now we have our BIM model of an office space from IFC BuildUp. This is what we've created. So we can move on to the installation of our hydraulic suite. So it follows along the workflow and moves into CYPEPLUMBIng Water Systems. So at this stage, I'm going to move to the software now. I'll exit the presentation. Okay, so the first thing that we need to do when we're starting a new project is I'm going to go to the BIM Service Center, which is our platform for uploading BIM projects to the cloud. From the platform, sorry, one sec. From the platform, users can also download new software, they can access updates, they can collaborate with other professionals from a huge variety of disciplines, and they can find new projects that are related to and require work from their own discipline. So this is a connection tool for all the different suites of SYPE. So it enables a connection between structural, hydraulic, electrical, telecommunications, HVAC, etc., all into one project. And it enables this simultaneous work of these different disciplines and the communication between all of the different elements, drastically reducing the time required for a project. So to begin, I'm going to create a project. And I'm just going to call it demonstration, a seminar, be visible and open. So with these settings, if you have an account on the BIM Service Center or you'd like to create one, you can search for me on the BIM Service Center using the search function here, and you can just search for Jacob Newson. And I'll leave this project as public, so you can access this after the webinar is finished. You can access the files that I upload, and you can have a look for yourself. Of course, I have the option of making my project private if I don't want other people to be able to see. Yes, it's up to me. I get to control the visibility of my project. Okay, so I have my project. The next thing that I would do is I would install the software that I'm looking to use. So if I go to the store, and for example, I want to download IFC BuildUp. I just open it up in the store, download, and it's going to download as a zip file, which I can then extract. You can see I've downloaded it plenty of times. So if I open up the folder, run the installer in English. Okay, this is my zip folder, don't need that. Okay, so if you continue with the installation, you will reach a step here where it will ask you if you'd like to install the BIM Service Center synchronizer. And so this is a desktop application that ensures the files of the projects developed in the BIM Service Center are up to date. So it communicates between the Service Center and the local machine that you're using, and it has to be running for the workflow to function. So make sure that you leave that box ticked. So now we've installed our software, we can begin with IFC BuildUp. So as I said earlier, it's a free site application designed for the creation and maintenance of IFC buildings. For the sake of this demonstration, I'm going to use a pre-configured example file for an office so that we can save some time. However, through the program, it's possible to create thoroughly complex structures and export them to your project or to any BIM modeling software that you wish. So I will load offices. Yep, okay. So using the program, we have created a simple office building. You can see here, we can scroll through the floors. So with a finished building model, I can export this. Oh, sorry, just before I export, I'll show the 3D view of the building. Okay, so there you go. This is our simple office building, which we will be using today for the plumbing installation. Okay, so I can export my building model. I select the project that I will associate it with, the demonstration project we just created. Accept. The name is fine. I'll accept. So it'll just do a last check of the geometry of the building to make sure that there are no errors, and then it will export finished. And now at this stage, it's going to use the Service Center synchronizer, and it's going to upload that to my project on the cloud. Okay, so finished uploading. So it's worth noting at this point that you'll notice today's demonstration is quite quick, quite brief. So if you'd like more in-depth descriptions of how to use any of the plumbing software, please utilize our YouTube page, where we have a lot of videos. A lot of work has been put into these videos. They're in multiple different languages. We have a playlist for CYPEPLUMBING with extensive videos explaining in a lot of detail each of the tools of the software. But today I'm just going to briefly go over how to connect between the different programs of this plumbing suite. And if you're a site customer, you are guaranteed free technical support for all of our software. So if you have any trouble, please just call it the technical support. Okay. So moving on, we have our building model. We can now open the OpenBIM water equipment. So I'm signed in. Let's create our water equipment. I select the project, demonstration, accept, next. Now it's going to load in the files associated to this project, which will be our IFC building model. It's fine. Finish. I get to select which floors I would like to import, all of them, and which of the precinct types, which of the rooms, designated rooms. So I'll load all of those as well. Okay, import is successful. Okay, so here we have our building. Okay, so we have all of the floors. And so for today's demonstration, I'm going to work with this bathroom here on the ground floor. And so you can see the architect has put in the desire for 2 sinks and a toilet. And so I'm going to actually put in a 3D model for a toilet and 2 sinks. So we'll be able to see that in our building model. So I'll start with the toilet. That's fine. Place that there. And the sink, the 2 circular sinks. Okay. And to change the orientation, we just have the tools on the left. And I just left click to place those into the model. Okay. And so just quickly, we can have a look at our 3D model. Okay, so if I go down to the first floor bathroom, we now have a 3D model of the sinks and the toilet inside our BIM model. Okay, so we can export this. That's all we needed to do in the water equipment program. Export, we don't need any drawings. Export finished, accept. It will load the file on the synchronizer. And so you can see now how smooth this workflow is and will continue to be. We've got 2 programs open right now, editing our project, and I can move between them freely. I'm going to open up a 3rd program now, which will be the water systems. So I'm signed in, new file, water supply. Select my project. All of the programs operate in a very similar way, so it should all be familiar. It's the same steps for each different program. So here we have the importing stage. So we have our IFC building model, and now we also have the Open BIM water equipment. So I will import that as well. Okay, so now we have the configuration. So again, we load the floors, we load the rooms, and here we have the configuration for the standards that we're going to use for water supply. So as you can see on the right side, we have a number of flags to load pre-configured standards, such as the European Union, the British standards, we have America, etc. We also have tools for importing customized standards as well. So if you create your own standards, your own checks for all the different appliances you're going to install, you can export that, save it for your next project. And for today, we're going to use the British standard. So I can import that and it will fill all my configuration settings automatically. For example, if I open up the horizontal pipes, we can see that it has introduced a minimum velocity, a maximum velocity, and the same for my vertical pipes. So when I create an installation and run the analysis, it will make sure that my installation meets the standards of the British standards 6700. And another really important tool is our dimensioning settings in the calculation options. So in this window, you can configure your preferences for the different dimensioning tools of the program, and you can set it to prioritize making the pipe diameters as small as possible to save on material costs, or you can set it to prioritize a minimum available pressure requirement. So this takes us back to the start of the presentation when I mentioned that all the software has this efficiency at its core, whether it's determined by the user, of course, but you can choose between economical use versus economical installation. So I can set it to be minimum diameter if I prefer economical installation, but I'm going to choose the minimum available pressure requirement. So this way, our system will be designed to minimize the need of a stronger pump, basically, to save on energy costs and reduced power usage. So I can accept, and you'll see what I mean in a second, but I'll accept. And so now that our configuration is complete, we can select next. And the last step is just to assign the, so the consumption types that we have in this building. We obviously have the toilet and the 2 sinks. And so the program just needs me to assign or designate what they are called in the British standard. So the British standard comes with a list of appliances or consumptions that you can install. And I just need to make sure that those are correlated to what I've installed in the building model. So for toilets, we have a cistern, and for sinks, I can just use a hand basin. And finish. And it will take all that information and load our building model with the standards, normative checks ready to be applied. And so when installing a water systems or a sanitary systems, the installation always has a start point and an end point. And so if we move to the ground floor, we can see here, well, in this installation, these are our endpoints. So we need a start point and we need to connect it to our endpoint. Okay, so usually for water supply systems, your start point is going to be a supply connection given by this tool here, supply connection point. So I open this up. And so you can see here we have the general data where you can input the temperature, the flow, the pressure. But you can see this lock tool here. When you see this symbol, it means that it isn't necessary for you to alter this variable, as the program has the ability to use context to assume that value. So if you would like to overwrite the program's assumption, you can of course input your own value, and then you must lock it in so the program doesn't override it. So we can leave all of this open and accept. And I will place my water supply connection point just down here. And so now we need to connect it with some pipes. So I'll use my horizontal pipes. Oh, sorry, I just need to introduce thermal insulation. That's fine. One second. Thermal insulation for our pipes. Accept. Okay. So for our horizontal pipes, here we can select cold water, hot water, the different types of pipes that we've loaded. We have 2 different horizontal pipes loaded. In the general data, again, you can see the locks, so we don't need to alter any of this data if we don't want. And we have options for flow. Again, if you access the editing tools, you can see that all of this information will be automatically loaded by the program using context. So we can leave all of this, the program will assign it. So we can accept. And starting from our water supply connection point, I will go up like this, across, and I'm just going to connect to our cold water supply, like so. Okay. For today's demonstration, I'm not going to be connecting a hot water unit, just so we can keep this simple, but it functions the same. And if you would like more information, again, please check the YouTube page because there's extensive videos explaining how to do so. Okay. So now that we have connected our pipe, we can see here that there's a number of checks in the window on the right, but we're going to run our calculation. So if I go up here to my update results tool, you can see that we've hit a couple of errors. These 2 errors are simply for not connecting the hot water, which is fine, we can ignore those. But if I go to this tool here, you can see that the velocity isn't reaching the required value. It's not falling within the range set by the British standard. And it's the same, I believe, yes, for this pipe as well. So now that we have these errors, there's one very useful tool in the program which we can use, which is the dimensioner, which will take the information that you've inputted and it will try and use that information to recalibrate your installation. I'm going to use the manual one sec, sorry. I believe we don't have, yes. So you can see the lowest pipe diameter that we have is a 20 millimeter diameter. So if I go into my general settings and my pipe catalog, I can manually introduce a smaller pipe that we will require for this installation. For example, a 16 millimeter pipe instead of a 20 millimeter pipe. If I accept that, automatically dimension it, and now it has gone into the library of pipes and found the best choice, which is now this smaller pipe, and the velocity is now adequate. If I can do the same for this pipe, yes. So it is selected the smaller pipe. Again, if I run the dimensioning tool here, this is a universal dimensioning tool. So this dimensioner will only activate for the individual pipe. But if I run, sorry, I just forgot to accept. Make sure you click accept, not cancel. Okay, so if I run this tool, it will try to dimension the entire installation. So in this case, it has changed this pipe from a 20 mil to a 16 mil, and it has upgraded this from a 20 mil to a 32 mil. And so it has done this according to the dimensioning settings that we set in the beginning, which was for economical use. So it will try and design the most efficient system to minimize the requirements of our pump. Okay, so we have our water supply installation. We have a couple of tools for displaying the results of your installation, but I'll save those for once we've installed the sanitary system as well. So I'm going to export this installation, water supply installation, accept, it's been exported. It will export to my project. Okay, so I will now open the CYPEPLUMBIng Sanitary Systems. Again, this is going to be almost identical to the water supply systems. All of our programs are designed to run and operate in the same format, so it's intuitive to use. So I'll select my project. It will load the information. And so you can see we have the water equipment, and now we also have the water systems. So I'm going to import both. Make sure you tick that to import them. Click finish. We have our floors, our room types. Again, we have the configuration of the standards to use. So we're going to use the British Standard. Accept. Show again. It will automatically load in the design and normative standards required. Okay, so the next step, again, I just have to assign my my toilet and my sinks, wash basin, that's fine. Okay, so these are the names that are as they're assigned in the British Standard. Finish. Accept. Okay, you'll see the window looks very similar to CYPEPLUMBIng Water Systems. Here we have our endpoints, or in this case, for the sanitary systems, these are our starting points. For our endpoint, we have the supply connection point. So I can accept, and I'll place our supply connection point just out here. Again, we go to our horizontal pipes. It is an almost identical prompt as in water supply systems. You have your general data, your checks. Here you can select the pipe reference and the different types of pipes that you would like to use. These come directly from the library that you've assigned. So I can accept. And then starting from my starting point, I'm just going to draw a very basic installation like so. Obviously, you wouldn't normally design something like this. It's not very pretty, but for the sake of the demonstration, it fits. And you can see here the direction of the flow using the arrows next to the pipes. And I can right click to exit, and there's our installation. Very simple. So if I run the calculation, you can see that there are errors. And to check the errors, we can open up each individual pipe. And using the British standards, according to the British standards, the diameter has to be greater than 100 mils. So I can use my individual dimensioning tool again, and it will assign the best pipe to use, which in this case is exactly 100 mils. For the other pipes, I will use our universal dimensioning tool. Here you go, it has assigned all the pipes to be 100 mils. Okay, and that's as simple as that. We have our sanitary installation. So some tools to display the results of the analysis. We have here the graphical analysis of the results, which can display a number of different results directly onto the project, such as flow, velocity, slope. For this demonstration, let's have a look at flow. So we can see here we have our scale at the bottom, and it visually displays the results of the flow, which we can then we can set a range for that flow if we'd like. For example, if we want to see between 1 and 2 liters a second, recalculate, and there we go. Obviously, on an installation of this size, it's setting a range or something like this isn't as useful, but you can imagine for a full installation of an entire building, something like this is very useful to distinguish between the different levels of flow. If I open up our 3D view, the graphical analysis will carry over to the 3D view as well. So once I've finished this installation, I'm going to open up a finished example of this entire building completed, and that way it will demonstrate visually a little bit better the usefulness of this sort of graphical analysis. But yep, so that's the graphical analysis tools. The other tools for reporting your results, we have from the file button, we have reports and drawings. So if I open the reports, we have a number of different reports that are automatically generated, such as the design criteria, which lists all of the checks that have been run for your installation. We have results for the wastewater network and results for the rainwater network. Obviously, we don't have a rainwater network installed, but that's okay. Okay, so and a useful tool for collating all of these reports is our document tool on the right. So if I create a new document list, I can select which reports I want to use, like so. Accept, I can alter the order. If I want to change the order, and accept. And now I can use this document button to generate my finished report. In a professional format, it will have all of the results that you've selected. Okay, and the other tool is the drawings tool. So if I click on drawings, open up new. Here I have a number of tools for filtering what I would like to see in my engineering diagram. It's a mechanical design drawing. If I click accept and accept, it will automatically generate the floor plans with the sanitary installation included. So to see the details, we have a button here, detail of the drawing. And so it's not a very it's not a very, not a lot in our drawing, I should say, but you can see here is our pipe installation with everything, very basic installation obviously, but it has every detail included, with automatically generated legends and scales, which are completely customizable. All of the settings to customize your drawing are included in the program. Okay, so we have our installation, we've exported our results, our reports are all exported to our project. Let's export the installation to our project on the cloud. So here we have, if I would like to export my reports or my drawings, for this sake, I'm just going to leave those out, but I will accept, and it's going to export my sanitary installation. Okay, I think it has exported. So to check the export, we can go back to the BIM Service Center, move to my projects, demonstration. And so here we have all the tools for controlling your project, but I just want to see the 3D model. So I can make my architectural model transparent, sorry. And we can see here, we have the sanitary installation with the graphical analysis imposed, and we have our water supply installation as well, with the 3D models of our water equipment included. So everything has been exported successfully. At this stage, I'm just going to quickly go back to the presentation so we can finish this, and then I'll show you the finished product of what you can build with the hydraulic suite. So all of this data, so we've gone through our water systems using our architectural model, configuring our standards, designing our installation, looking at the results, and exporting our reports and our drawings. It was the exact same workflow with the sanitary systems. It's a very simple workflow, very intuitive, and this moves right across the hydraulic suite. So we have CYPEPLUMBING solar systems and CYPEFire sprinklers, all operating in the exact same format. We have, and finally in the hydraulic suite, we have CYPEGAS. So we've had, if you can imagine, we've made all of these different installations for our office project. They've all been uploaded to the cloud. So you can see it's all moving towards the left. It's updating our BIM model, and now it's moving into the BIM Service Center, like so. We're here on our project. All the different installations are uploaded onto the exact same building model where they can, all of the information is interacting and communicating. So in this way, the BIM manager can see all the project data from each of the different disciplines working together. In this way, it removes these barriers of communication that I was talking about earlier between the different disciplines, and it enables a simultaneous workflow as all of these can be created simultaneously, all these different installations. So the final product of this workflow is all the complete plans for every discipline involved in the construction project, all integrated with each other, and all with the accompanying and required documentation. All documentation is created to meet the building requirements of the code that it belongs to. So I hope this gives you a good idea of the benefits of this workflow system that we've created to use with the CYPEPLUMBING software. And I'll now move to show you what a finished product can look like when constructed through CYPEPLUMBING. So if I open up the water supply systems, for example, and I load our finished office, sorry, I've got a couple of questions. Okay, so in regards to the two questions, these are a little bit specific for the demonstration today, but I will send you the answers to those questions directly. If anyone else is interested in that information, please let me know, and I'll send you a detailed response. Okay, so here we have our finished installation. As you can see, we've installed both cold and hot water. and we've installed it on every floor in the building. Okay, and so if I move to the 3D view, we can see what a detailed installation looks like. I'm just going to slowly build up to this. So, okay. So we begin with our office architectural model. We then move to water supply systems, where we install our cold water supply, our hot water unit, and connect the entire installation of the building. Our sanitary system is then installed with both wastewater and rainwater installation. Then this building has also included CYPEPLUMBING sprinklers installation, CYPEPLUMBING HVAC installation for your air conditioning and heating, and the CYPECAD installation for structural analysis. So if I remove my architectural model and I'll just get rid of CYPECAD, you can see all of these installations interacting successfully. And so when all this information is collated by the BIM manager, he can make changes necessary for each of the disciplines, and all of that information is uploaded back to the creators of each of these installations so that they can make changes simultaneously. This communication is completely seamless. So yes, this is our finished installation. And for example, I'm just going to remove the other installations. I can run my graphical analysis of the flow. Let's try the graphical analysis of the velocity and calculate. So here's our graphical analysis of the velocity, which I can then display on our finished installation. If it wants to load, let me just see. Velocity, go from, yes, that's fine. Okay. And so here you have what I was talking about earlier. You can see the graphical analysis of the results of the velocity throughout our architectural model and the difference between the ground floor and the higher floors of the building. So yeah, this is a very useful tool for displaying your results of your installation graphically. Okay, so I hope that you can see a little bit about how our workflow can create a system that gets as close to possible to removing all these miscommunication errors between the different disciplines that lead to these unforeseen costs in projects. And with that, I think we've reached the end of the demonstration. So I hope you've enjoyed and that you can now understand a little bit about the potential application for this software. So if you have any more questions, please send them through now. I'm happy to send a recording of this webinar to anyone who would like it. If you would like that recording, please just leave your email address in the chat. And yeah, again, for more in-depth videos into the tools available in this software, please check the YouTube page. And for Ramizar, I will send you the answer directly. Yes, so I'll just wait a minute now. If there's any more questions, please leave them in the chat.